Several people have been asking about this calculation of the percent relative standard deviation. So I thought, why not just make a video about it? And that way I can put that up there and everybody can see it, and everyone can see how to do it right when they need to know how to do it. So the equation that you're supposed to use looks like this, where the sigma Greek symbol is the standard deviation, and this is actually equal to the square root of 1 over n sigma I equals 1 to the n parentheses x sub I minus the mean population squared. Yeah, right. So what this means in English, for your particular sample where you have 3 different samples, is you're going to take the average, that's x bar. You're going to subtract the first data value that you used to make the average, number 1 measurement. You're going to square that, and then to that you're going to do the same thing and add together the average minus the second data value squared, and then to that you're going to add the average minus the third value squared. So add all of those little differences that have been squared together, and then you're going to divide by the number of measurements that you've made. So in your case, 3 measurements. So that's going to be 3 in your case, minus 1. So this whole thing at the bottom is 2 for this particular measurement, and that will equal your standard deviation. So let's take a look at some data and actually give this a try so you can see how this works. So let's say we have 3 experiments that we're measuring the same thing. And if you're going to be measuring the standard deviation, you have to use measurements of the same thing. You're not looking at standard deviations of different measurements. Okay, so we measured the same thing 3 times, or at least it should be the same thing, and you got the following values: 1.2 grams, 1.4 grams, and 1.3 grams. So the average of that, if we add up those 3 things and divide by 3, is 1.3 grams. So x bar, 1.3 grams. Okay, this first value is x1, second value is x2, and the third value is x3. The number of measurements we've made is 3. So we know everything we need to now in order to calculate the standard deviation. So let's try it. 1.3 grams minus, first data point, 1.2 grams squared, plus the average again, 1.3 grams minus, here's the 1.4, 1.4 grams squared, plus average, 1.3 grams, minus the third data value, 1.3 grams squared, all over n, which is 3 minus 1, and I'll take the square root of it. Okay, so what does this evaluate to? 1.3 minus 1.2 is 0.1. I'm going to square that and get, what, 0.01? Most likely, but let's just double check on Mr. Calculator. Yep. So I have 0.01 for right here. 1.3 minus 1.4 is negative 0.1. I'm going to square it, so I get 0.01 again, and plus 1.3 minus 1.3 is 0 squared is still 0. All of this over 3 minus 1, or 2. So we get 0.002 grams. This is grams squared at this point, because we squared the grams here. So 0.02 grams squared divided by 2 equals 0.01 grams squared. Alright, I take the square root of that value, and I get 0.1, 0.0101. New calculator, sorry, bear with me. Duh. 0.1. Grams squared, square root of that is grams. And there we go. So that is your standard deviation for this particular data set. You probably won't come out nearly quite so nice because you have numbers that aren't quite this reasonable in terms of just 1.3 and 1.2, but there's your value at that point. So now this standard deviation is 0.1 grams. To find the percent relative standard deviation, we just take that number. We're going to divide by the average, which is 1.3 grams, and multiply by 100 in percentage units. So our answer will be in percentage units. So 0.1 divided by 1.3 times 100 gives us 7.69%. And we only really have one significant figure for this, so 8% is our percent relative standard deviation for this measurement.